Hello, students! This is an educational video created by Scholars Academy for ICSE Class 10 students. Welcome to this explainer. Today, we're getting completely hands-on to demystify a topic that literally forms the absolute backbone of your algebra syllabus. I'm talking about quadratic equations. Now, I know this topic can sometimes feel like this massive, unbeatable hurdle, but I promise you, by structuring our approach and just breaking down these concepts step by step, it's going to become entirely manageable and honestly, maybe even a little fun. We're going to build up your toolkit from the ground up so you can confidently tackle absolutely any problem the board throws your way. Okay, let's dive into our roadmap for today. We are going to cover standard form essentials, solving by factorization, and the quadratic formula. Then we'll get into the nature of roots, translating word problems, and we'll wrap the whole thing up with some exclusive ICSE exam pro tips.
Section 1, Standard Form Essentials. Right, before we can even think about solving a puzzle, we need to know exactly what the puzzle looks like, right? The crucial starting point is understanding this exact structure. ax squared plus bx plus c equals 0. This right here is the standard form of a quadratic equation. X is our unknown variable, and a, b, and c are our known numbers. But hey, pay really close attention to that little condition there. A absolutely cannot be equal to 0. Why? Well, think about it. If a is 0, our x squared term completely disappears, and suddenly we just have a boring old linear equation. The x squared is literally what makes it quadratic. Getting your equation into this neat descending order of powers is step number 1 for literally every single solving method we're about to discuss.
Moving on to Section 2, Solving by Factorization. Now that we know what a quadratic equation actually looks like, let's open up our very first procedural toolkit. We call this method splitting the middle term, and it is just wonderfully logical. Really, don't let the algebra intimidate you here. It's basically just a number puzzle. Step 1, as we just learned, is to arrange your equation in standard form. Step 2 is where the puzzle comes in. You need to find two specific numbers. These two numbers have to multiply together to give you the product of A and C, and they must add together to give you B. Once you find those two magic numbers, step 3 is super simple. You just break apart or split that middle bx term using those numbers, group your terms together, and factorize. Let's see how this brilliantly illustrates exactly what we were just talking about. We've got the equation 2x squared minus 9x plus 10 equals 0. Let's find our puzzle numbers. So our a is 2 and our c is 10, meaning they multiply to 20. Our b is negative 9. Okay, what two numbers multiply to positive 20 but add up to negative 9? Negative 4 and negative 5. So we split that negative 9x right down the middle into negative 4x and negative 5x. From there, we just pull out the common factors, which leaves us with two brackets. 2x minus 5 times x minus 2 equals 0. Using the zero product rule, we easily get our two roots, x equals 5 over 2 and x equals 2. It's clean, it's elegant, and man, is it efficient. Section 3, the quadratic formula. But what happens when the numbers aren't friendly? Or what if you just freeze up during the exam? Hey, do not panic. Enter the Sridharacharya method, which is universally known as the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. I know, at first glance it looks like a monster, but really it's just a simple set of instructions. It literally tells you exactly where to plug in your a, b, and c values from your standard form. Think of it as the ultimate master key. It will unlock any quadratic equation regardless of how messy or complicated the numbers get. Just notice how incredibly mechanical and foolproof this process becomes. We have the equation 3x squared minus 12x minus 1 equals 0. We simply extract our coefficients. A is 3, b is negative 12, and c is negative 1. And we just carefully plug those straight into our formula. The negative b becomes a positive 12. Under the root, negative 12 squared is 144 minus 4 times 3 times negative 1. This simplifies down beautifully to 12 plus or minus the square root of 156 all over 6. From there, you just simplify the surd to get your final two values, which are roughly 1.69 and negative 0.44. See? The formula did all the heavy lifting for us.
Section 4, the nature of roots.
Okay, here's where we take a really cool analytical deep dive because we can actually predict our answers before we even finish solving the equation. This is all thanks to the discriminant, which we denote with a capital D. Notice that D is just that little piece of the quadratic formula that lives right under the square root, b squared minus 4ac.
Believe it or not, this tiny little expression dictates everything about your roots. There are 3 absolute critical conditions you must memorize for the ICSE boards. If d is greater than 0, you are guaranteed 2 distinct real roots. If d equals exactly 0, you get 2 identical equal real roots. And if d is less than 0, meaning it's a negative number, well, you can't take the square root of a negative in basic algebra, so the equation has no real roots. We call those imaginary roots.
Let's actually look at this in action with the equation 2x squared minus 3x plus 1 equals 0. We want to know the nature of its roots without doing all the work of solving the whole thing. We compare it to our standard form and extract a equals 2, b equals negative 3, c equals 1. We calculate d, which is b squared minus 4ac. That gives us negative 3 squared minus 4 times 2 times 1, which simplifies down to 9 minus 8, which equals 1. Because 1 is a positive number, it's greater than 0, we can immediately guarantee that this equation has 2 distinct, real roots. Having this tool is incredibly powerful for checking your work on the fly.
Section 5. Translating word problems. When we look at past ICSE exams, we notice something interesting. Students rarely struggle with the pure algebra. Nope, the absolute hardest part is often just translating the English sentences into math. So think of this as your quick cheat sheet. When an exam question talks about consecutive integers, you methodically assign your variables as x and x plus 1. If it says consecutive even integers, it's x and x plus 2. For age problems, which are super common, always set the present age to x. Then 5 years ago is simply x minus 5, and 5 years from now is x plus 5. If you methodically translate the English vocabulary into these algebraic expressions first, I promise you the equation practically writes itself. Let's see how this builds into the famous train problem that ICSE just loves to test. Remember the golden rule for these scenarios. Time equals distance divided by speed. The problem gives us a fixed distance of 1800. We let the normal speed be x and the increased speed be x plus 300. The time difference between the two speeds is 1 hour. So we literally just translate this. The time taken at the slower speed, which is 1800 over x, minus the time taken at the faster speed, 1800 over x plus 300, equals exactly 1 hour. From there, you multiply through, simplify, and boom, you have your quadratic equation, x squared plus 300x minus 540,000 equals 0. The setup is literally everything.
Section 6, ICSE Exam Pro Tips.
As we enter our final review, I want you to lean in close for these, because these are your secret strategies. Here are your golden rules for the exam. Rule number 1, always write out the standard formula before substituting your values. Examiners actually award step marks for this, and it totally prevents those silly substitution errors. Rule number 2, verify if your final root actually makes sense in the real world. In that train problem we just did, or in literally any age problem, if you solve the equation and get a negative number for speed or age, you must explicitly state that you're ignoring that root. Why? Because speed and age cannot be negative. Failing to reject that illogical root will absolutely cost you crucial marks. And rule 3, double check your signs. One dropped negative sign on your b value will cascade and ruin your entire solution. Well, we have covered a whole lot of ground today, from the rigid structure of the standard form to the analytical power of the discriminant, and finally to conquering those tricky word problems. So I want to leave you with this final provocative thought. How are you going to apply these foundational scaffolding techniques to your upcoming ICSE mock exams to secure maximum marks? Keep this structured approach in mind, practice methodically, and you are absolutely going to ace your math boards. Thank you so much for learning with Scholars Academy today, and keep calculating.